Hello, everyone, and welcome to today's session. Today, our speaker is Ryan Bowie. He's a cloud solutions architect at Microsoft. Ryan has over 20 years of application development experience working in technical leadership, architecture, development, and support delivery roles, helping customers, partners, and ISVs envision and progress innovation ideas into functioning application, solving real-world business and engineering challenges. From line of business applications running mission-critical enterprise workloads to time-sensitive real-time software running robots and lasers on the plant floor, Ryan's background in development has spanned across many verticals, technologies, and platforms. Ryan has been at Microsoft over 14 years in many different roles in Microsoft: services, consulting, support, and most recently, helping enterprise customers across the US understand how to leverage cloud computing effectively as a cloud solution architect. Ryan, I'll hand it over to you.
Yeah, thank you very much for that introduction. So today, there's been a number of sessions in the past on our IoT platform, IoT Hub, IoT Central, and some of our capabilities that we have. And one of the things I want to talk about or dive a little bit deeper into today is some of the solutions we have in our platform for enabling you to connect and interface with industrial IoT devices. So by that I mean things like programmable logic controllers that might be running an assembly line, or robots that are on the plant floor, and which tends to require and necessitate some additional pieces of software. Particularly things that are called the OPC server. I'll talk a little bit about that, as well as some of the nuances and features that we have in our IoT Edge platform in conjunction with IoT Hub to be able to pull data from those devices. So, taking a step back a little bit, I want to highlight for those of you who may not have some background on this, and what exactly I mean when I talk about IoT on the edge. So, we have cloud native services that run in our Azure data centers to be able to allow you to manage and operate, deploy, monitor devices at scale. And by devices, it could be something as simple as thermostats in your home to something more sophisticated like automobiles, or in the case that we're talking about today, maybe a factory with an assembly line with a number of sensors and pressure transducers and proximity sensors and so forth that you want to be able to monitor and capture data from. So typically when it's involving something that's running a critical operation in a business, such as on a plant floor, the dependency and reliance on an internet connection to be able to make those critical operations function tend to make customers nervous about deploying something where there's a dependency in that wide area network connectivity. So we have, as part of our solution stack, a feature called IoT Edge that actually allows you to do a number of different things on localized devices that are running inside your plant, or I actually have one customer who actually has them running in very large pieces of industrial mining equipment. So it doesn't matter what the actual location is of these devices, but basically you can take pieces of the Azure cloud essentially and run them locally on a compute device where you can capture and interface with data that's being generated from in our case that we're talking about today, a plant floor. And I should have let this build out a little bit more. I forgot I had a couple more bullets on there. And then, the other thing is the other benefit that the IoT Edge provides, specific to that first bullet, is that having a device physically close to, say, a programmable logic controller running a robot reduces that latency and the time it takes for data to flow from that device up to a cloud and back. You can minimize that and keep it in close proximity to where that device is running. And the benefit there is if you have a control loop. So let's say when this pressure transducer hits this particular pressure, react and change change the state of this valve as an example, or actuate a pneumatic device that actually changes the state of a valve. So you want that to react, or those sorts of things to react very quickly when you're running in a plant floor, and IoT Edge allows you to be able to do that sort of thing. So I talked about a number of features that IoT Edge provides, with the ability to move a lot of cloud-based capabilities down to a localized device running in case we're talking about today, in a plant floor, while still allowing you to be able to monitor and update and manage those devices at scale from the cloud. So being able to do things like changing what, if you're familiar with programmable logic controllers, there's a concept of tags, and we'll look at that in a moment. If you wanted to be able to change the sets of tags that are being monitored by a device, you can be able to push a new configuration down to devices in all of your plants, select plants, or maybe a particular line in a particular plant. So that the cloud management capabilities are very powerful to be able to provide some features to be able to support that. A couple of things that I wanted to highlight: if you're taking a journey on capturing telemetry from from industrial devices, this is just more of kind of a warning slide, or kind of word of caution slide, that I'd like to extend to all of you, in that to think about capturing telemetry first, and then devise ways to be able to extract additional business value from that telemetry. And what do I mean by that? So I'll give you an example. So I'm working with some customers wanting to optimize some of their assembly line operations to be able to improve their product quality. And yes, there's some features in Azure we can use to do that, anomaly detection capabilities, machine learning models that we can train with some of this telemetry. But starting with a smaller initiative tends to be, think of it as like an agile sprint. Customers tend to be more successful with that approach, as opposed to trying to do a very large project all at once. So just kind of think about that as you're going down the road of getting data from industrial devices and pushing it up to the cloud. All right, so the IoT Edge runtime. So we talked a bit about the fact that this is a piece of hardware that could be running Windows or Linux on your plant floor, and it could be as underpowered as lightweight as something like a Raspberry Pi, or in the case of some of the industrial customers I work with, they have some very high-end i7 series machines that actually run machine learning models inside the plant. So it runs the gamut in terms of what sort of hardware that could support. So the IoT Edge device has a runtime running on it that offers the capabilities to be able to interact with that device from the cloud. And one of the important concepts of this I want to highlight, just from a security standpoint, is it's very firewall friendly. So you can actually have this running inside your facility, and it actually reaches out to the cloud, and the cloud never establishes a connection to the device. So that's important from a security standpoint, because we support a number of common ports and protocols, such as AMQP, MQTT, and that can actually traverse over port 443, which is a common port that's used, or that businesses tend to allow traffic to go out over. And the IoT Edge runtime also is kind of the monitoring daemon that makes sure that different modules that are running on that device are in a running state. So it monitors what the desired state is being pushed from the cloud, and looks at what the current state is with the modules running on the edge device, and determines if a state change needs to occur. And when I say modules, the modules are actually, I'll talk about that here shortly, but the modules are just Docker containers that run anything from an Azure function to custom applications that you're writing, or what we'll look at today is our Industrial IoT footprint and capabilities that allow you to take data from industrial machines and equipment. and let this build out. So this is actually a picture that kind of walks through what exactly is involved in the deploying an IoT Edge device. And I'm going to build out the slide, and then I'm going to hop over to show you a IoT Edge device that I have running on a VM in Azure right now. So what you do is you have any sort of compute device. Like I said, in my case is a virtual machine running Ubuntu. When you have that device configured and provisioned, you deploy the IoT Edge runtime components onto that device, and that the IoT runtime components include a number of capabilities that are kind of deployed on here, to be able to support this functionality and capability. The Edge runtime. There's also some capabilities I'm not going to talk about today that allow you to provision devices at scale, and by that I mean if you picture a IoT Edge device maybe with a trusted platform compute module in it for security purposes. You can actually use that chip embedded in the device to basically announce itself to the cloud and say, I'm device XYZ. In Azure's IoT Hub will know, what hub that in the cloud that device is associated with, and communicate back to that device and say, this is the endpoint or the URL that you need to actually communicate with. So it provides some capabilities when you think about like manufacturing vehicles, where you have a vehicle made today that did not exist yesterday. So this is a common capability that's used for being able to provision devices as they come off the line. It's not required to be able to do some of what I'm going to show you today. So after the device is created, you go into IoT Hub and you indicate what node that you actually want to deploy to that particular Edge device. So by that I mean what sort of modules or functionality you want to deploy, and you can define that definition in the IoT Hub, and that configuration is pushed down to the Edge. So what this is actually depicting is that there is what's called a device twin that's stored in Azure that actually depicts what the desired state is of the modules you want to deploy onto the Edge. And by that I mean what sort of containers and so forth you want to have running on the Edge. So inside that manifest that the IoT Edge actually pulls down, it will say, I need to run, go out and grab the Hello World module. I need to go out and grab the, in our case, the Microsoft Azure Industrial IoT module. So these are just Docker containers that are then running on the Edge. So the benefit of this entire platform is that it allows you to be able to easily and quickly deploy functionality down to the Edge and manage it from the cloud, and not need to worry about deploying heavyweight virtual machines to be able to deploy all of these bits of capability, because the container modules are lightweight Docker images. So also on the IoT Hub, you actually define the message flow. So how do you want data to flow, maybe from this module to this module and up to the cloud, or maybe from this module to this module and this module up to the cloud. So you can actually define that path, and then you can define the any additional configuration metadata that you want to pass down to these modules. So when you think about a container, the way you pass configuration parameters to them is typically through things like environment variables, or telling the Docker container to be able to mount a a folder that's sitting on the local file system on the Edge device. So all of that configuration metadata too is established in the IoT Hub and then pushed down to the Edge. So there's a couple other important points I'd like to highlight here, is that in addition to running custom functionality as Docker images on the Edge, there's a number of Azure services that can actually run on the Edge as well. So Azure Functions, Azure Stream Analytics, machine learning, some of our AI cognitive services can actually be deployed as modules down to the Edge. So let's take a look at how that works in action. So I have here a IoT Hub, and you can see just from the graphs that I've got some messages flowing at the moment. And I'm going to go to my IoT Edge management. So I have a singular Edge deployed in this particular case, and when this loads up, So I'm just going to go ahead and drill into the configuration of this particular device. So this device has a number of modules that are defined to be running at all times on this particular edge device, and there's two of them that have a $sign. So these are the system modules. This is actually the IoT Edge runtime itself. So I said earlier that when you whether it's a physical device or in my case it's a virtual machine running Ubuntu. It could be running Windows, Linux, ARM, x86. We support Edge on a number of different types of devices. The system modules is the actual runtime elements needed to be able to support the communication back to IoT Hub, to be able to manage the life cycle of modules running on the Edge and so forth. That's why they're prefixed by this $sign. But the advantage here too is that you can actually define the version of the IoT Edge runtime that you want to run across all of your Edge devices, centrally from IoT Hub. So just quickly show you that as an example. When I go in here and actually go to runtime settings, I can actually define what the container image is used to be able to run and support the IoT Edge runtime components. I can put the version number in here and provide a number of other Docker container create options that we'll look at here in a moment. So there's a couple other modules that I have deployed onto this device, and I'll pop a link in the IM window here shortly. But what is running on here is our Azure Industrial IoT modules. I'll go ahead and pop it in right now, just so everybody has that. So this is a Microsoft authored set of Docker images that we provide customers to be able to support communicating via the open process communication protocols to industrial equipment you might have running on the plant floor. So in my case, I have 3 of them deployed on my Edge device. So the important one that actually initiates all the communication with some of the OPC servers you might be working with, whether it be Kepware, Siemens, Rockwell Automation, the plethora of OPC servers out there. And I'll show you a bit about that here shortly as well. So OPC Publisher. You can see it's actually coming. It's a Microsoft hosted and supported module. And if I go to container create options, there's a number of parameters that I'm passing to this particular container when it starts up. Particularly, I'm telling it how often it actually posts data back to the IoT Hub. That's what the interval is here. As well as the sizes of the messages that I want to accumulate data on inside of my module before I actually make a post to IoT Hub, the name of the site that I want to be surfaced up to the OPC servers that I connect to, and then there's some other interesting configuration metadata that I wanted to walk through today that isn't that well documented, and hopefully you walk away today with knowing how to wire all this up. There's a configuration file that I'm passing to this module that actually defines all of the different data points that I want to pull out of my programmable logic controller, robotic controller, and so forth. So you can see that it's actually coming from a path called app data. And the way that these module configurations work is that this is a typical Docker configuration metadata that you can provide modules. And by that I mean one of the things that you can do with Docker is provide a binding to say this physical directory on the host machine running my container is exposed to this directory that's inside of my container. Because containers, if you've not worked with them before, they're immutable. So that means that if that container crashes and dies, when it restarts, any data that was written to the inside of the container image itself is lost. It's not persisted unless you actually wire up a directory inside that container to a directory that has more durable storage, like on the Edge itself. So I'll have a folder called IoT Edge that you'll see on my Edge device, and it's going to the app data folder inside of the container, and you can see that I'm referencing a file called pn.json. So that'll become very important when we start diving into some of the configuration. So with all of that in place, I am now switching over. Whoops! I'm switching over to my. If I could type here, I'm switching over to my IoT Edge device. So this is an Ubuntu VM running in Azure, and you can see that it has a number of containers running on it, including the IoT Edge agent and the IoT Edge hub. So those are the two system ones that don't show up on here. And then I have 3 user-defined modules I have running on here that are part of the Industrial IoT pack that I posted in that IM link. That's an OPC Twin, Discovery, and then OPC Publisher. So what I can actually do is change the behavior or version of these particular images from IoT Hub. So without having to connect to SSH to maybe hundreds of devices that you have all across the globe and different plants, you can actually centrally manage and control that in IoT Hub and push that configuration down to devices, and I'm doing it one by one, but I'll show you here in a little bit how you can also do that at scale. So I mentioned too the concept of routing, and this has to do with that diagram I was showing where you can actually define messages from this particular container go into this container or go up to the cloud. So in my case, I have all of my containers going into this special endpoint called upstream, which basically means I'm pushing the messages from these modules up into IoT Hub. But I could instead actually just say I want to go from OPC Publisher maybe to the Discovery service as an example. So you can kind of create that definition here if you were authoring modules yourself and wanted to stitch all that together. I see somebody said it's too small of a font, so I'll go ahead and zoom in a bit. And just for the sake of zooming back in, I'll show you what I was talking about with the storage bindings. All right, so that is the IoT Edge runtime bits, and that's been discussed on other programs and shows on different channels. I didn't want to dive deeply into that. I just wanted to showcase really quickly what an edge is. In my case, is a VM running Ubuntu, and you can deploy containers to it. So let's talk a little bit more about how this particular set of modules come into play to be able to pull data out of a programmable logic controller or robot controller or CNC controller and so forth. All right, and as I mentioned on this particular slide, that the devices could be as kind of in this constrained level of device capabilities, with very small amounts of memory and small amounts of compute capabilities, such as a Raspberry Pi, up to very high-end iSeries industrial PCs that they're running machine learning applications locally. So we have a number of device vendors and hardware vendors that we partner with that are on the Azure IoT Edge website to be able to that are compatible with our software. All right, so for those of you who might not have some background on the open process communication stack and kind of what that means, there's a consortium that backed by a lot of heavyweight industry players, and I'll go ahead and let this kind of back out a little bit, that defines the layering of communication and methods that you can use to interface with devices running on a plant floor. And this is kind of talking about the different protocols involved in some of the layers. So down at the bottom, most plants have many sensors, motors and actuators that might be using very specific protocols such as ModBus or DeviceNet, EtherCAT, Profinet. There's all these different industrial protocols that these manufacturers employ to be able to talk to programmable logic controllers. And programmable logic controllers are the brains that typically run, assembly lines or industrial control applications. And then typically there is some sort of manufacturing execution system or SCADA environment, a data historian that captures data, maybe alerts maintenance staff when something goes awry, some supervisory council basically. And typically this is some sort of PC-based application, running on x86 hardware that needs to communicate with those PLCs using a specialized software that I'll talk about in the next slide, the OPC software, to be able to pull data out from that. And there's a number of different protocols: OPC Classic, OPC UA, DDS, PLC Open. These are all different ways that these pieces of software use to be able to talk to the PLCs. So, if you're using a Siemens PLC, a very specific software and protocols you need to use. If it's a Mitsubishi, if it's a GE Fanuc, if it's Rockwell, all of these programmable logic controller vendors have software that you use to be able to talk to them. And then typically, on top of all of that is some sort of centralized system that actually pulls, for inventory control or ordering, purposes, or billing purposes, data from the manufacturing execution system up. So this is a typical tiered layer that you would see in a manufacturing environment. So the OPC Foundation, it has a lot of members in it. You can see these are some of the industry heavyweights I was just talking about. So these are all organizations that are sitting on the board to define some of these standards to be able to make it easier to talk to the plethora of devices that are out there. And this is a eye chart of a typical environment that you might be faced with when it comes to a production or assembly line environment. And what's important to note on here is that these pieces of equipment, whether it be devices or sensors, basically everything I just showed on that triangle diagram, the programmable logic controllers, these supervisory, SCADA workstations pulling data from the PLCs, or the MES environments that are kind of sitting above that, they typically tend to be deployed in different layers on the OT network in a particular industrial environment. And what the OT network is typically cordoned off from the IT business network that you might use to stream your favorite music, or to be able to load up line of business applications that are running on the corporate network up here in orange. And why this is important to highlight is it tends to be a challenge to for security reasons to be able to bridge these two gaps. And that is where IoT Edge comes into play very nicely. And this is showing a number of different machine scenarios where each one of these dashed lines kind of represents the different machine with another IoT Edge deployed. So there's an IoT Edge. This one has some analytics, machine learning jobs running on it, and it actually is talking to the OPC server, the same OPC server that the supervisory station might be using to talk to the PLCs, and it can actually pull data directly from the PLCs and interface directly with sensors and the physical devices that are involved in making the machine work. So having a localized piece of hardware that you can deploy into this isolated red network I'm showing here on the left is incredibly powerful. And there's some additional illustrations of that using other protocols, whether this case is using MQTT, this case is using LoRaNet. In this case, it's actually showing a module running on the IoT Edge. It's actually using a IP-based camera. So a number of different ways that you can employ this. And all of these messages go up to a centralized place in this IoT hub, and you can use all of the plethora of Azure cloud services to be able to do interesting things with that data once it's pushed up. So we'll take a look at that here in a moment. So as I mentioned, that OT and IT network segregation, the IoT Edge provides a unique opportunity to bridge that gap between the OT network that tends to not be at all connected for obvious security reasons to the cloud. It can sit in the middle and provide a facility to be able to send those messages. So let's take a look at how this comes into play. So I have here, this is a Windows VM that I have running in Azure. And I have a number of different OPC servers running on this Windows server. But one of the ones that I have running on here is this one from Process. There's all kinds of OPC servers out there. Like I said, Kepware, Rockwell, Siemens. I didn't pick this one for any particular reason, other than that it makes it very easy to expose simulated data points to an OPC device. So basically, think of this as my PLC or my interface to the PLC. So the way OPC servers work is they actually have what are called tags that represent memory locations inside the programmable logic controller. So that memory location could be a bit indicating what the status is of an actuator, if it's extended or retracted. It could be a word that actually has maybe the status of a bunch of different actuators as in different bits in that word. Or it could be maybe that word represents an analog pressure reading from a sensor running on a plant floor. Or it could be strings. It could be a number of different data types. And the way the OPC server works is you actually create a tag and point it to a memory location in the programmable logic controller, and you give it a human readable name. And you can see there's a number of simulated values that I have in here: a counter, random, sawtooth, sinusoid, square, and triangle. And I can actually go on these particular tags, and I can actually see what the value is that's being emitted. I can control what the min and max is. So this is actually a really cool way to be able to simulate communication or traffic from an OPC server. And they also have some commercially available. This company has some commercially available OPC server software that you can use to interface with PLCs as well. So in this case, every one of these values has a node ID. So this is actually showing what namespace is running in and what the ID is of this particular tag. So where this comes into play is, if you recall, the configuration that I talked about for the IoT Edge. So my IoT Edge is actually sitting on the same network in Azure as my OPC server. So they're both deployed in central US, and I have a private network. If I go ahead and just go to the not going to be able to zoom in very easily on that, but you can see that my IP address is 172.17.05, and I'm going to go to my my edge device. And if I go to my Ethernet, I can see 172.0.7. So they're both on the same virtual network in Azure, which allows traffic to flow back and forth between these machines privately, similar to how they would be deployed in a plant environment. Okay, so we have our OPC server running. We have our edge device up and running. How do we connect all this together? Well, if you recall, in my edge configuration, and I went to the OPC publisher, I have this special file that I'm referencing, and I'm saying this in app data, and it's called pn.json. And remember, app data is actually mapped to a physical folder on my edge device called IoT Edge. So if I open back up my edge, I can see I'm inside of that folder. I have a number of different versions of this file that we'll talk about here in a little bit. And I'm just going to go ahead and cat that file out. And there's a couple of important elements of this file. So this is now serving as the configuration to this OPC publisher module I was just showing. So I'm telling it where it's connecting to. And if you look at the name IoT OPC server, this is actually the fully qualified private DNS name of this particular OPC server. And if I go back to my Windows VM just to connect the dots, it is right here. You can see the complete name running at port 53,530, So that is the address of my OPC server. And then I'm defining what tags that I want the OPC publisher module to ingest from my OPC server. So if you remember in my OPC server, if I go back to that again, and go to objects, you can see namespace 3 I1002. And you can see that I have that defined right here as well. And I'm also putting in some details of how often I want it to sample that data and how often the OPC server is actually publishing that data, and I'm giving it a display name as well that I'm using to actually push this data up to the cloud. So I have all this stitched together, and there's some command line tools you can use on an edge device specifically. I'm just actually going to go right to root, and because this is actually running as a Docker container, you can actually use all the typical Docker commands, including Docker logs. And my module is called OPC Publisher. So when I go to this is actually showing the log file because it's been running for much of the day. I can see periodically it puts out this stamp, and I can see what it's talking to, how long it's been talking, how many data changes there have been. So 52,000 data points and 69,000 value changes. So what this means is how much I pulled. This is how many times there's actually been a state change of that pulled data. And the other thing that I can see that is really important from a billing standpoint is messages that are sent to IoT Hub are billed in 4K increments. So what this is actually telling me is based on the number of tags. So I have 3 tags that I'm watching every couple of seconds. They're changing at a pretty high rate of speed. I can actually see how many 4K messages that equates to in the course of a day. So 17,276 messages. So you can actually see, like if I go to the pricing tier of my hub, then I'm running this S1 standard tier. And if I go to overview, it'll actually tell me that I actually have 400,000 messages at this particular tier because I only have 1 scale unit. So if I said I want a 2 scale unit, it would double it at this tier. So this actually directly corresponds to what the price is of the messages flowing in. So you saw that for the data I'm watching, it equates to about 17,000 messages a day, which falls well below that. So that's how you plumb everything up to be able to get data from the OPC server to the edge, and now the edge is publishing these messages to IoT Hub. So now what do you do with that data? So one of the many things that we have in Azure that you can use to view and manipulate that data is, or not necessarily manipulate, but see that data, is something called Azure Time Series Insights. So data coming from mechanized equipment tends to be time series based, where there is a event-based data arriving in a series from pieces of equipment on the plant floor. So time series insights works really well and can couple very tightly to IoT Hub. So it provides some simplified capabilities to do some visualization and kind of rudimentary analytics. Allows you to create dashboards and maybe show all your devices across plants and data coming in. You have some alerting, and you can also plumb this into some of the anomaly detection capabilities we have in Azure to be able to kind of trend data over time and alert you if there's any issue with or abnormality with data as it's coming in. So let's go ahead and look at how this works when be able to connect this to a time series insights database. So I'm going to go ahead and go back here and go to time series insights. So this takes a couple minutes to create, which is why I'm not going to create it for us while you guys watch. But if I go to this is when you create a time series environment, it asks you what data source or data sources you want to use to feed the time series environment. So I go to event sources. I created one called IoT PC. And when I go into this, you can see this actually bound to my demo hub IoT environment. And what's noteworthy here is you can actually, so the IoT hub has different access policies. So in this case, the IoT hub owner access policy and key is actually representing somebody who or a through when it's using the API under the covers to be able to get data out of my IoT hub, has the ability to delete those messages and interact with the hub in its entirety. So you can actually create, maybe if I only wanted my time series insights environment to be able to use a key that had read-only access to my hub, I can actually do that. So I'm telling it that the data is coming in a JSON format to my hub. So one other thing I want to show before I kind of jump into it, and I have oh, not there. So in the documentation for the I'm now looking at the OPC publisher documentation. This actually shows what the messages look like that are actually emitted from the OPC publisher environment that's running on my edge. So I can actually see the data points. There's a value that comes in, there's a timestamp that comes in, and then there's also a publisher ID that comes in with every message, and a node ID that's actually in the header. So that this node ID actually tells me what the name is of the node that's actually emitting this data. So in my case, it's OPC server. The process OPC server will actually be my node ID, and I'll show you that when I start diving into it. So why that's important is that my time series environment, when I created it, I told it that I wanted to partition my data based on the node ID. So every emitted message is going to have a different node ID for those tags I'm capturing, so that allows them to show up differently in my time series environment. So what I'm going to do is go back to my time series portal here, and if I click this link, it's going to open up this window. And what I can see here is I have a number of different data points that I'm pulling in, and the ones that I'm actually collecting from my OPC server is the sinusoidal, sawtooth, and random data points. I'll talk a little bit about slow data and fast data here in a minute. So I've actually given them some names, and I can actually map all of that here. So if I go to the sawtooth one as an example, I can see that this is actually the 1003 data point. This is actually how it's coming in from my IoT Edge device, and I just put a friendly name on it so I can actually graph and chart it on my screen. So time series insights, I can actually go in here and drill into a particular period of time. I can actually see it, over a longer period of time, or just a narrow window of time. So this allows me to see the data at a very granular level and zoom in. I can also make it auto refresh. You can see the sawtooth random and my sinusoidal data that's coming from my PLC, which is the equivalent of getting data from your programmable logic controllers on the plant floor. So this is kind of connecting the dots of being able to pull the data out from simulated environment. We have another thing that you can use that I will post a link to. Let me go back here. It's actually in a GitHub repo that I'm slowly building out. So one of the other things, what I'm gonna show is actually changing my IoT hub to actually talk to a different type of simulated device. And actually, the reason why I'm not seeing it is, let me just go here. It's actually in this one. So I'll drop this link in the IM window too. So we have a a Docker container that you can actually use to paste it in the IAM window here, that you can actually deploy to use it as a means of sending or simulating data coming from a programmable logic controller. So this is actually a little bit more restrictive on kind of the data points that you can actually expose. So like in my OPC server, I was actually giving, sinusoidal, and I had some options of being able to emit different types of data that I could actually test and simulate. And what this is a container that generates a bunch of different types of data points. So that you can't really configure it beyond what's shown here, but there's some random data, sine wave data, or just positive and negative values. So you can deploy this in a number of different ways. And an easy way to deploy this in Azure is using something we have called Azure Container Instances. So instead of needing a VM or instead of needing a Kubernetes cluster, I can actually take this container image and actually deploy it very quickly into a container instance environment, which is billed by the second and allows me to host any container. So if I drill into this, just to kind of show you how this works, I go to containers. This is the actual container that is running, the one I just pasted the link to, the OPC PLC. And if I can actually connect directly to this container from this environment as well. So now I'm actually directly inside that container, so I can actually see what's running in it. And you can see that there's the same pn.json file inside of this simulated container that's generating my fake random data. So the other thing, let's see if I go to logs. I can see that when it starts up, it actually gives me an address. This ACI Contoso PLC East US Azure Container.io running at port 50,000. So what I can do with that is, instead of having a VM with an OPC server on it, what I'm going to do is change my edge, and it looks like my shell locked up. So let me just go ahead and get right back in here. Make this a little bit bigger for everyone. So in here, you can see the address that I have in here. The ACI Contoso actually directly matches this. So again, container instances just makes for an easy receptacle that you can actually push a container into and run it. And then I have a couple of tags that I'm actually pulling from that as well. So I can actually see these are all the different tags that my OPC server is exposing. And I can see how often it's actually sending, it's publishing changes of this data. And some of the fast changing data points should be a little bit faster than 10 seconds. So these are basically published immediately as the data changes. So what I can do in my on my edge is actually tell it, instead of going to my OPC server running on a VM, to use the one that's in a container. And I'm giving it some names. And so what I'm going to do is copy pn ACI JSON to pn.json. I'm going to restart my container. And I'm going to look at it running, and I can see that it's now talking to the Azure Container Instance, the East US Container.io at that port 50,000. So I'm now talking to this other simulated device. And if I let it run for a second, I should start getting some messages. Some of those data points change a little bit infrequently. but then I should be getting data that is coming into my time series Explorer. If I go move this to the beginning, you can see that the data has stopped coming in for those data points. And if I add one of these, so what I'm doing is I'm hiding my other data and seeing if we start getting some of this other data coming in. So this is actually from the my test PLC data, and it hasn't started coming in yet. But you know, the point of this is to show that we have commercially available modules to make it easy to talk to OPC servers. You can configure what data points you want to get from the OPC server and send it up to the cloud. You can use time series insights to actually quickly visualize that data. And then you can also do some interesting things in IoT Hub. You know, maybe you know this is a good visualization of real-time data coming in. And maybe you want to send this data into a data lake to be able to do things like, you know, apply some machine learning models on top of this data. So IoT Hub has this concept of message routing, and I can actually take these messages and send it to a storage account, an event or service bus, event hub. So I have a number of different options where I can route this data, and I can also create a query. If we recall, the messages coming into my IoT Hub is just JSON, so I can actually tell the IoT Hub that I only want to take messages for this node or this OPC tag and dump it into a storage account as an example. So you have some flexibility to kind of route messages out of IoT Hub into a storage account that you can use to do some other analytics. And then the final thing that I would like to show is I'm just going to go to a device here, and I have a number of IoT Edge devices. This is another hub that I have, and I mentioned that you can actually make deployments at scale. So this is where things can get interesting, that you can actually create a configuration and actually apply it to a number of devices. So I'm just going to go to this one right here. And what this is saying is I want to, my target condition is with the device ID equals IT Edge. So I can actually put in tags on my Edge devices running around the globe saying plant 1, line 1, you know, maybe Asia, plant 1, line. So I can actually put in some very specific tags on those Edge devices. And I can actually target with this deployment what Edge devices I want this deployment to go to. So where are you going to start seeing some similarities? I was in the portal looking at a single IoT Edge that I had. If I go to modules, you can see again, you know, the system modules. In this case, I have a temperature tester that I'm actually deploying. You know, it's coming from a different container image or container registry. The routes, all of the configuration I showed you in the earlier example when I was doing it through the portal, you can actually define that in here as a deployment, and you can actually download this deployment definition and use this to deploy through CI/CD pipelines. And I can also see if I go here that I have one device that it matches, and it's actually applied this configuration to one of those devices, and that the one device that it targeted actually reported back as being successful. So this becomes very powerful when you start having many IoT Edge devices that you want to update or change or alter the behavior of. So some pretty powerful capability there when it comes to being able to create deployments instead of clicking in through the portal into the Edge device and changing it as I did here manually. So hopefully that provided everybody with a good overview of how to get data from pieces of equipment you have on a plant floor using an Edge device, the Industrial IoT modules that I posted a link to, and then I talked about a couple of different ways that you can simulate data if you don't have a programmable logic controller that you want to interface with directly right now, or maybe your security team has some restrictions over what you want to connect to or what you're able to connect to, and you have to simulate it to maybe show how you can devise some interesting ideas of what you can do with that data as it gets posted to the cloud. So the my primary goal and objective of walking through this is it tends to be a fairly complicated topic. OLA it used to be called OLA for process control. Now it's called open process communication. Is because as you saw, the tags sometimes have cryptic names and identifiers to them, and sometimes it's not really clear on how to wire things up if you've not worked with this before. So hopefully it's provided a good overview of that. OPC Simulator free trial. There's a number of them that are free. The one I showed actually is free. It doesn't allow you to connect to devices for free, but the simulator part of it is free. Some of the OPC simulators, like from Kepware, I think it runs for 2 hours before it stops emitting data. And the other option that I showed you, this Azure Container Instance option, which is the second link I posted, it basically is it's a Docker container that acts like an OPC simulator, and you have some configuration you can provide it, and how many slow values to emit, and how many sinusoidal values to emit, and so forth. This too is free, but it's not an actual OPC server. It's just a Docker container kind of emulating that. So hopefully, it looks like that's the only question. And if there's no other questions, I'll go ahead and hang out for a couple more minutes if anybody else has any other questions. But this is what I wanted to kind of walk through and show.
Ryan, can I please say something?
Sure.
Okay, so first of all, I want to thank you all for joining us, and thank you, Ryan, for putting together such a great session. If you're not already part of the Reactor community, please do consider joining us on Meetup or directly through our Microsoft page. You can also follow us on Twitter, or even check this session or previously recorded workshops on YouTube on the link I shared already before. And finally, if you have any feedback at all about how the event went, we'd love to hear what you have to say. But please, I also sent the link for going to and doing the survey, but please use the code 12669. And thank you so much.
All right, thank you.
I believe you got a question, Ryan.
Can we connect Arduino to IoT Hub, or do you need Raspberry Pi in between? That is a good question. So there's a couple options there. We have a SDK. In fact, I think there actually is one for. There's a module. Yep, there's a library. So you can actually connect directly from a Arduino to the IoT Hub without needing anything in the middle. You could, alternatively, if you remember from my picture, if that wasn't entirely clear, I kind of glossed over this part of it because it wasn't part of my talk. You could actually have a Raspberry Pi that runs the IoT Edge, and it mimics what the capabilities that IoT Hub has, and this is showing downstream devices, IoT Hub with an SDK. So that would be like your Arduino or something using Bluetooth Low Energy. So these would be devices that don't have a full-blown operating system like an Arduino, that actually can connect to an Edge, and the Edge behaves like an IoT Hub and can take messages from that and route to the cloud. Or that module that I that I posted a link to can actually bypass this and go directly to the IoT Hub. The reason why it is sometimes preferred to go behind a device like an Edge is for security reasons. That this device might be sitting on a more isolated network in a production environment. You probably wouldn't be using an Arduino, but it could be some other type of intelligent connector or intelligent sensor or something like that. And having an Edge in the middle actually does a couple of things. First of all, I talked about latency. You can actually minimize the latency of the device going directly to the cloud. If this link goes down, the Edge can actually store messages from these devices until that link comes back up. And like I said, it serves as kind of a transparent gateway to the hub. So so you don't have to have a Raspberry Pi, but that's or some other type of edge device that is sitting in the middle. But it's often the case when you're using intelligent sensors and devices. All right. Don't see any other questions. It looks like it's the top of the hour. So, if there any other questions, definitely. I don't know, Faris, if there's a email DL that's available. All right, that sounds good.
All right, thank you so much, everyone. Thanks again, Ryan.
Yeah, no problem. I'll talk to you guys later. Bye.